perception, opening the doors of 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 perception.
Hat sich Rupert Sheldrake für Biologie interessiert und sich schon seit der Schulzeit auf Naturwissenschaft spezialisiert. Er studierte Biologie und Biochemie in Cambridge, aber schon bald wurde ihm die riesige Kluft bewusst zwischen seinem ursprünglichen Interesse, eine Erklärung für das Leben und lebendige Organismen zu finden, und der orthodoxen, materialistisch-mechanistischen Biologie, die Menschen und Organismen auf bloße Maschinen reduziert. So begann er, sich mit der holistischen Tradition in der Biologie zu befassen und fing an, die Theorie der morphogenetischen Felder und der morphischen Resonanz zu formulieren, die die Grundlage des unsichtbaren Bauplans bilden, der für die Form und das Wachstum von lebenden Organismen bestimmend ist. Seine ganzen Forschungen gelten bis heute diesem Modell der morphogenetischen bzw. morphischen Felder. Nach seinem Studium der Naturwissenschaften in Cambridge und der Philosophie in Harvard promovierte er in Biochemie und lehrte am Clare College in Cambridge, wo er Forschungsleiter für Biochemie und Zellbiologie war. Als Forschungsmitglied der Royal Society forschte er an der Cambridge University über Pflanzenentwicklung und den Alterungsprozess von Zellen. Von 1974 bis 1978 war er leitender Pflanzenphysiologe am Internationalen Landwirtschaftsinstitut von Hyderabad in Südindien, wo er die Physiologie tropischer Gemüsepflanzen erforschte. Für dieses Institut blieb er bis 1985 beratend tätig. Die perfekte Brücke zwischen östlicher und westlicher Tradition bildete der Ashram von Pater B.D. Griffiths in Südindien, der ihm die Basis für eine breitere Philosophie und ein umfassenderes Naturverständnis bot. Dort schrieb Rupert Sheldrake 1981 sein erstes Buch, Das schöpferische Universum. Viele weitere Bücher folgten dann, Das Gedächtnis der Natur 1988, Die Wiedergeburt der Natur 1990, 7 Experimente, die die Welt verändern könnten 1994, zusammen mit Ralph Abraham und Terence McKenna, Denken am Rande des Undenkbaren, und zusammen mit Matthew Fox, Die Seele ist ein Feld, und Engel, die kosmische Existenz. Sein neuestes Buch, Der siebte Sinn der Tiere, ist ein Bestseller und bekam die Auszeichnung Scientific Book of the Year. Rupert Sheldrake lebt in London und ist zurzeit Mitglied des Institute for Noetic Studies in San Francisco. Rupert Sheldrake, es freut uns sehr, Sie auf die Bühne empfangen zu dürfen.
Thank you. I welcome this opportunity to explore the ideas of unity in duality, which Tarab Tulku has put before us. I was very stimulated by his paper, which is one of the clearest expositions of Buddhist philosophy that I've seen. And in my talk, I'm going to be reflecting on Nagarjuna's pairs of opposites, and also on Tarab Tulku's development of them. I shall quote from his paper, which all of you have in this book, he didn't have time to mention all these points in his talk last night, but I hope that these quotations will make clear what he's saying. First, I want to say something about the background of Western science and philosophy, because when dealing with the relations between Western science and Eastern philosophy, we need to bear in mind the Western philosophical tradition as well. A great deal of influence on Western science came from the early philosophy of Greece. The early Greek philosophers were preoccupied with a question which probably came from the East, which probably was due to a mystical insight. Through mystical experience, many people have found that there's some timeless realm beyond the changing world we experience. The ancient Greeks had this idea. I think the primary insight was mystical rather than intellectual. And one of the problems that the first generation of Greek philosophers were grappling with was to try and understand what it was that was changeless behind the world of change that we experience. They came up with different answers. For Pythagoras and his followers, the changeless realm beyond the changing world we experience was the realm of mathematics, of numbers, ratios, and proportions. Plato was very influenced by Pythagoras, but he generalized Pythagoras' ideas to say that the eternal realm was not just mathematics, but the ideal forms of things, the archetypes of everything there is. And he thought of these as eternal ideas in a realm beyond space and time. The materialists, Democritus and his fellow materialist philosophers, came up with a different way of understanding what doesn't change. They said what doesn't change is matter. Matter is the changeless ground of everything we see, but matter is broken up into lots of little bits called atoms, and it's the movements of the atoms in the void, their permutations and combinations that give rise to the changing world we experience. So the changeless basis of everything was supposed to be little bits of matter which were inert, changeless, passive, and unconscious. The philosopher Heraclitus had a different view. He said the only constant thing in the world is change itself. Well, these were the sorts of ideas that were going around in Greece, and many of them were brought together in a great synthesis by Aristotle. Aristotle was a philosopher of becoming. These ideas were all ideas that tried to understand a kind of static being. But Aristotle was the only philosopher I know of who was a biologist, and his primary concern was understanding becoming, the way in which plants and animals grow, for example. And so his philosophy integrated some of these ideas. He showed that the materialist view was unsatisfactory and superficial, and he produced a synthesis which came to dominate subsequent philosophy, and which became the orthodox philosophy in Europe during the Middle Ages. By the end of the Middle Ages, this had become rather sterile, scholastic, repetitious work. And the founders of modern science rebelled against Aristotle's philosophy. The modern science was based on a rejection of Aristotle's view. Aristotle said the whole world is alive. Animals and plants are living organisms with souls. All animals have souls, all plants have souls. The soul is what organizes the body. But modern science was based on rejecting that view, saying that nature is a machine, it's inanimate, it has no soul. It's just made up of matter in motion. And the science as we know it in the 17th century was founded by a revival of two of these main ideas from early Greek philosophy, Platonism and materialism. All the founding fathers of modern science believed that the ultimate reality were eternal mathematical laws. They thought that God was a mathematician, and that he thought the laws of nature permanently. So nature was governed by eternal mathematical laws. The people who were most like God were mathematicians, and they were the ones who were best able to appreciate fundamental changeless reality. This idea, of course, continues to be popular among mathematicians. But on the other side, there was a revival of atomism. This was promoted by a number of people, including the English philosopher Thomas Hobbes, who revived the idea that nature is made up of inanimate matter. And he also extended atomism to social philosophy, that society is made up of atomic individuals. And he laid the foundation for the kind of individualist social and economic philosophy which still forms the root of neoliberalism and dominates the politics and economics of the world today. It was based on a kind of social atomism. This materialist basis for science, it actually created a dualism within science. There was eternal matter, atoms and movement that went on forever, that were conserved forever, that underwent no change, governed by eternal laws. So there was a permanent amount of matter and energy which didn't change, except it got rearranged, but it got rearranged in accordance with eternal laws beyond space and time. And this was the dualism on which classical mechanistic science was founded. Of course, there have been many changes in science, and probably one of the most important is the way that, as the philosopher Karl Popper expressed it, through modern physics, materialism has transcended itself, because matter is no longer its fundamental explanatory principle. Matter itself is explained in terms of fields and energy bound within fields. So the idea of a permanent, unchanging stuff as the basis of reality has been discarded by physics. But although physics has transcended materialism, in many ways biology has remained locked into a kind of 19th century materialist view of the world. And this, I think, has had some advantages, but it's also held back investigation in biology quite considerably. And I shall come on to that later. With that background, I now want to look at the pairs of opposites of unity in duality according to Nagarjuna, the great Indian philosopher, as expounded by Tarab Tulku. There are four pairs of opposites according to Nagarjuna, fundamental pairs of opposites which are really dualities which have a unity behind them. The first of these is the duality between becoming and cessation. The individual, the nature of the individual, involves these two poles of becoming and cessation, or if you like, life and death, or growth, maturity and death. This is how Tarab Tulku expressed it. As we look more closely into phenomena, it appears that becoming and cessation of a phenomenon does not just happen once in a lifetime. In order for a phenomenon to uphold its existence, this pulsation of becoming and cessation takes place within every split second. I'll leave it to our physicist colleagues to talk about how this applies to the modern view of matter as an oscillatory, vibratory pattern of activity. But this is also clearly true of living organisms. We know that within the organism there's a constant replacement of cells, of proteins, and of other chemicals. The living organisms are full of cycles of activity, daily cycles, in women monthly cycles, annual cycles, and then of course much quicker ones like the heartbeat and the breathing, the brain waves, and then much quicker cycles still in the biochemical reactions inside cells and in the oscillations of proteins. So this becoming and cessation is an ongoing process in all living things. So this idea of Nagarjuna's is certainly borne out by the insights of science, both in physics and biology. But becoming itself is still a mystery because of the atomistic bias of modern science, because of the reductionistic tendency that was built into science early in its history. The ability to explain how complex wholes come into being is one of the great unsolved problems within biology and also within chemistry. The first picture, please, shows a familiar sight, snowflakes, more familiar in Germany than in England. And here you see, this is a very familiar kind of image, but what's so interesting about snowflakes is that each one is different. Yet, each arm of a given snowflake is the same. Now, this poses a really big puzzle, because if you say, well, each one's different because of chance, that's plausible. You can explain the differences between snowflakes by chance. But you can't explain the similarities between the arms of the same snowflake in the same way. Clearly, there's a correlation between the way these grow and stop growing. This is becoming and cessation, actually in a visible form. The becoming and cessation is literally frozen into the shape of the snowflake. The fact that each arm is the same as each other arm means that they must be correlated with the way the others are growing. That means there must be either some kind of organizing field for the whole snowflake, or at least some kind of resonant interaction between the growing arms. Neither of these are ideas which are understood within modern chemistry and crystallography. This was a big problem. Johannes Kepler, one of the founding fathers of science, wrote a monograph on the six-sided snowflake, pointing out some of these problems, and they're still unsolved today. So even in the realm of chemistry and crystals, the process of becoming is not really understood within science. Of course, there are certain common factors. All these snowflakes have 6 arms, and in terms of the structure of chemistry, the unit cell of water crystals, we can explain the 6-fold symmetry. But what we can't explain are the individual details that make each snowflake different from the others. Thank you. We can have that off now. The second pair of opposites, which Tarab Turku talks about, is the time nature of phenomena. And this is what he says. From the universal perspective, becoming, being, and cessation are to be viewed as an infinite, uninterrupted stream of unfolding, becoming, and enfolding, cessation, and at the same time, from the perspective of the individual identity of phenomena, a phenomenon is subject to its particular becoming, being, and cessation, implying finity. Well, again, this seems to fit very well with the findings of modern science. The snowflake, for example, will melt, but it's part of a process of the water cycle, falling of water or snow to the earth, evaporation, refalling. It's part of an ongoing cycle of activity in the water. So the individual snowflake is part of a much larger process that continues over a much longer time. We can see the same with living organisms. Every plant, every animal is a member of a species. It comes into being, it grows, it dies. But life goes on. And one of the discoveries of the last 200 years is that life involves a constant current, an unbroken current. Each one of us is alive today because there's a constant, unbroken current of life going back through our ancestors, right back to the very origin of life on Earth. All life on Earth is thought to come from a single origin. That's why we all share the same kinds of DNA and amino acids and proteins. And this single origin of life, those first cells, have given rise to all living things that exist today. This is another principle of unity in multiplicity, because all life comes from a common origin. We're related to all other living things. There's no break in life going right back to the beginning. Of course, many organisms have died before they reproduce, but all of us are the descendants of organisms that have lived long enough to reproduce, otherwise we wouldn't be here. And in the 19th century, it was still believed there was a spontaneous generation of life. This was the great controversy in which Pasteur was involved. What Pasteur showed was that all life comes from other life. So this is actually a fairly recent discovery. And of course, the evolution of life is a relatively recent discovery too. But what they show is that our individual lives and all individual lives are part of a vast current of life stretching right back to the beginning. Since the 1960s, cosmology has moved onto an evolutionary basis. Before the 1960s, the universe was supposed to be a vast machine, gradually running out of steam until it ended up in a thermodynamic heat death. This gloomy picture dominated a lot of thinking by gloomy intellectuals in Western Europe because the whole of life seemed totally pointless. Evolution could occur on Earth, but it was all doomed to extinction in the end, and the whole universe would eventually freeze in this kind of heat death. Well, we don't hear much about the heat death of the universe nowadays because since the 1960s, cosmology has moved on to a totally different model. More than 100 years after biology, physics has adopted an evolutionary paradigm, and we now have a radically evolutionary cosmology where everything started with the hatching of the cosmic egg, or the Big Bang as it's called in physics, a primal unity which split up and expanded and has been growing and cooling ever since, rather like a gigantic developing organism with new forms and structures appearing within it. Underlying all this process of becoming and all the fields which shape the processes of becoming is a current of energy. Energy is one of the great unifying principles of science. Again, this was a 19th century discovery that all forms of energy are interchangeable. And it's one of the great contributions of 19th century science that we can see everything that exists as part of an ongoing flux of activity or energy. The energy that runs through our lives goes back into the world around us through heat, through our excretion, and through all the different ways we release energy, and is part of the general cosmic flux of energy. Energy can take any form. It can be converted to light, to heat, to mechanical work. There are many forms in which it can exist, but the same energy is believed to carry on as an ongoing current through all the changing phenomena of life. This is embodied in the principle of conservation of energy, which is a fundamental tenet of physics. So here too we have a process, this time nature of phenomena, where in the words here that I quoted before, from the universal perspective, becoming, being, and cessation are to be viewed as an infinite, uninterrupted stream of unfolding, becoming, and enfolding sensation, and at the same time, from the perspective of the individual identity of phenomena, a phenomenon is subject to its particular becoming, being, and cessation, implying finity. Well, I think this makes very, very good sense in the light of both physics and biology, as I just said. However, there's another implication of this view of time in the Tibetan philosophy, or in the Nagarjuna's philosophy, which hasn't been drawn out properly within modern science. If time is a unit, if there's a unity in this stream of time, then there are connections between the past and the present and the future. One of the ideas I've been working on for 20 years in science is the idea there's a kind of memory in nature given by the process I call morphic resonance, an influence of similar things upon subsequent similar things, so that everything in nature, every self-organizing thing, draws on a collective memory. So there's an influence through time from the past to the present. This is this is still very controversial in science, of course, because the usual view in science is that the universe is amnesiac. It has no memory. Simply things, there's only a memory of where things are and how fast they're moving, but not of pattern or form. That the stability of the universe is not given by memory, but rather by eternal laws outside space and time. I think instead that the regularities of nature depend on habits rather than laws. This is a more organic metaphor, and also I think one that's more appropriate in an evolving universe. This is something which would be interesting to discuss. I hope there's a chance to discuss this with Tarab Tulku, because the implication of a memory in nature, which I think is really important for understanding the fundamentally evolutionary nature of things, is something which Eastern philosophy has accepted, but which Western philosophy and science, generally speaking, has not. Thirdly, the extension in space of phenomena is the third principle of opposites which are unified in duality, unity and duality. Here the quote is, "The nature of phenomena implies that apart from the outer matter nature, phenomena simultaneously possess an inner energy nature. The inner nature of phenomena is not simply confined by the matter extension in space. The more deeply we penetrate into the inner energy nature of phenomena, the more the boundaries spatially open, i.e., the phenomena become less spatially confined, therefore to a greater and greater extent delocalized." Well, this I think is most interesting because one of the things that became, one of the limitations of materialism that became clear right from the outset in 17th century science, in the great synthesis of Isaac Newton, was that matter, conceived of as dead, inert, and so on, yet had an influence at a distance, indeed an influence which stretched through the whole universe. Newton's vision was in fact one of extraordinary interconnectedness. His theory of universal gravitation said everything in the universe is interrelated. All material bodies influence all other material bodies in accordance with Newton's law of gravitation, proportional to the product of the masses and divided by the square of the distance. So Newton said all matter is both material and delocalized in this curious and mysterious way which he couldn't explain. Newton had no idea how gravitation could work because he thought it inconceivable, as he put it, that brute matter could have an influence at a distance. He thought gravitation, in fact, depended on the activity of God, and he thought that space was the sense organ of God. A very interesting idea. Newton was a most interesting theologian, but this side of his work is generally forgotten. However, it's a very good way of trying to conceive of divine omniscience. God knows what's going on everywhere because God is space, or at least the space is the sense organ of God. So anyway, that's how Newton explained gravitation. His followers forgot about God and the sense organs of God and couldn't explain it at all, but simply took it for granted. Then Einstein came along, as we heard this morning, and formulated a field theory which meant that all phenomena, the whole universe, is included within the universal gravitational field. And rather than the field being produced by matter, matter is produced by the field. And then what's the field made of? According to Einstein, it's made of space-time itself. It's not something in space-time, it is space-time. So this delocalization of matter is fundamental to modern science. However, Einstein was not the first person to invent the field concept. That was invented in the 1840s by Michael Faraday, studying electrical phenomena. Before Faraday, there was no real explanation for electricity and magnetism. Until the 17th century, they were understood in terms of souls. The Greeks thought that magnets and electrically charged bodies had souls, and it was the soul of the magnet, within and around the magnet, that could influence other magnets at a distance. The delocalized aspect of things in the philosophy of Aristotle, and indeed in the philosophy right from the first Greek philosopher, Thales, was the soul. The magnetic field of the Earth, according to Gilbert, who was one of the pioneers of magnetic research, was the soul of the Earth. Magnets pointed to the North Pole because they were pointing towards that pole which was in the field. What we now call the field was then called the soul of the Earth. The 17th century revolution in science abolished souls entirely, including magnetic and electrical souls, which left magnetism and electricity with no explanation. Again, people didn't know how to understand them until Faraday reinvented the soul under the name field, and the magnetic soul became the magnetic field. And he showed that magnets have an area of influence around them which is delocalized, in the sense it's more extensive than the material magnet itself. The next picture, please. This is Faraday's first drawing of the lines of force around a magnet. And you see there are these influences, invisible influences around the material body, which have particular shapes, forms, And also, of course, there's a polarity. The north and the south poles of the magnet are definitely another kind of duality in unity. The whole field has a unity, but it has a duality within it, a polar nature. The next picture shows lines of force around magnets. These are a very familiar picture, of course. And you see the difference between the fields between magnets which are attracting, where the lines join up, and magnets which are repelling. Two north poles repel. The lines go round and the fields don't enter into each other. It looks as if this is symmetrical. Actually, it's not. If you shake up a whole lot of magnets together, what the repulsive forces do is make them switch around till they're all lined up the same way. So it's not as if attraction and repulsion, although they're symmetrical in one sense, they're not symmetrical in the sense that when you shake the magnets up, the repulsive forces cause the magnet to swivel around and join on with the others. If you've ever played with magnets, you'll know that this is the case. They have a self-organizing property, and they'll all line up together in the same way. The next picture shows how Faraday extended this idea to electrical fields. These are static electrical fields. This again is a picture of Faraday's, showing how space itself has patterns, forms, shapes, which go beyond the material objects within it. He called these fields, using the ordinary English word field, which already had a wide range of meanings. Its most general meaning is a region of influence. Faraday didn't know what fields were made of. He had two theories. One theory, which he preferred, was that fields were made of lines of force, which were prior to matter, and that were actually modifications of mere space, as he put it. That the field was primary and matter was secondary. His less favored theory was that the fields were made of subtle matter, or ether, of a very tenuous form of matter. Of course, in the 19th century atmosphere of materialism, the ether theory was the one that people preferred, and this was the theory that Maxwell developed into his mathematical theory of electrical and magnetic and electromagnetic fields. This is the theory that Einstein refuted or transcended in 1905 with his special theory of relativity, where he showed that ether doesn't exist, or at least that it's superfluous. Instead of this subtle matter, we just have fields. We just have electrical and magnetic and electromagnetic fields, which again are patterns in space. They're not made of matter. Matter and electrical phenomena are made of fields. Matter, according to quantum field theory, consists of energy bound or trapped within fields. Now, this extension in space of fields is something which is relevant, highly relevant, in my opinion, to biology, and yet an intensely controversial subject. In the 1920s, people who were trying to understand living organisms, and especially how they develop, how their form develops, came up with the idea that living organisms were surrounded by fields, more complex than magnetic or electrical fields. These fields were invisible organizing structures within and around organisms which gave rise to the shape of the developing organism. The reason they thought that you needed an idea of fields was because you can't explain the form of an organism simply in terms of the pattern, the things it's made up of. You can see the problem more clearly if you think of an architectural analogy. You can't explain the plan of a building, for example, this building, just in terms of the concrete and bricks and steel it's made of. If you demolished the building and analyzed it, you could find out all the chemicals that are in it, but the form would disappear. And if you go along a suburban street, you can see houses of many different shapes built of the same materials. The shape, the form of the building is not given by the materials. The materials are necessary for making the building, but they don't explain its form. The form is more like an idea than a thing. It doesn't weigh anything. It's not something you can get in a test tube and say, here it is. The architect's drawing is again, just a pattern of information on paper. It doesn't depend on the paper and the ink. It could just be an idea in the builder's mind. Yet it's real. The idea was that biological fields, morphogenetic fields, contain an invisible mold or form or building plan for the organism, and that these shape the organism as it develops. Since then, the idea of morphogenetic fields, fields concerned with morphogenesis, morphe means form, genesis means coming into being, fields concerned with the coming into being of form, this has become an accepted idea within biology. But there's a big diversity of interpretations of these fields. Most biologists say, all right, these fields exist, but they must just be a way of talking about standard chemical and physical influences, and we don't really need this field concept when we've explained it fully in terms of standard chemistry and physics. They're not really a new kind of field. Platonists, among whom many mathematical biologists can be counted, say if there are fields, what's really needed is a mathematical equation to describe the fields, and then we'll have solved the problem. But actually we won't have done, because biology is radically evolutionary. These Platonic formulae are transcendent beyond space and time. The field of the dinosaur, according to the Platonic equation, if it exists, would have been the same at the moment of the Big Bang or before the Big Bang. It wouldn't have been influenced by the fact that dinosaurs actually existed, and it would be the same today when they're extinct. But biology, in fact, is radically historical, radically contingent on what happens. And I think that the fields are a new kind of field, they're a real kind of field, but different from the known fields of physics, and that they have a kind of memory within them, given by the process I call morphic resonance. So they depend on what happened before. Each species has a collective memory. It draws on the forms and behaviour of previous members of the species, and each individual in turn contributes to these. These fields in biology are polar, like magnetic fields, and we can see this in the next picture. If you take a cutting of a willow tree and you put it in damp air, it forms shoots at the apical end, at the shoot end, and it forms roots at the basal end. If you make a ring round in the middle, it forms shoots at this end and roots at this end. It's just like cutting a magnet in half. If you cut a magnet in half, you get two complete magnets. We see a similar process in this animal, this simple animal. Well, here we are. Here's a kind of sea anemone. When it's cut here, it regenerates tentacles on this edge. This here is a dandelion, and it forms roots at the basal end above this cut and a shoot at the apical end, the end towards the top. So we see the same kind of polarity in living things, and we also see the way that they regenerate after damage. This was one of the reasons why biologists first proposed the idea of morphogenetic fields. Organisms are not mere machines. Mere machines don't have the ability to regenerate after damage. Field systems do. If you cut up something that has a field, like a magnet, each part of the magnet has a complete magnetic field. If you cut up a hologram, which is an interference pattern within the electromagnetic field, each part can retain the pattern of the whole. But if you cut up a computer into small pieces, all you get is a broken computer, because they don't have this same regenerative or field-like capacity. So this was one reason for people proposing the idea of morphogenetic fields. The fact that living organisms have phenomenal powers of regeneration, which could only occur if something more than the part contains the whole. And it's no use saying it's all in the DNA, because the DNA is the same in all the cells and can't explain how they all do things differently. The next slide shows the regeneration of flatworms. If you cut up a flatworm into small pieces, each piece can regenerate into a complete worm, and each piece also retains its polarity. So the head end of that grows a new head. The tail end of this piece grows a new tail. Animals, of course, like plants, have a polarity. which is one of the primary features of their morphogenetic fields. We have head-tail polarities, or top-bottom polarities. We also have front-back polarities and right-left polarities. In plants, of course, the primary polarity is shoots and roots. These are present even in the egg cells. And the next slide shows what happens if you take a dragonfly egg. The normal egg develops into a complete embryo. In this one, the egg was tied across at the middle and the top half was destroyed. This bottom half of the egg would normally develop into the bottom half of the embryo, but in this case, it retains its polarity and it develops into a small but complete embryo, showing, again, a field-like nature of the phenomenon, a polarity and also a capacity for the part to contain the whole. The next picture shows an even more remarkable process of regeneration. This is the regeneration of the lens in the eye of a newt. The lens was removed surgically, which is a kind of damage that would never occur in nature. And the eye forms a new lens from the edge of the iris, which would not normally be the way that the lens is formed. It's normally formed from folding in the skin on the outside. And it regenerates a completely new lens in a totally different way from the way it forms it during embryology. So it's not just a rerun of the way the eye formed originally, it's a completely new way of forming a lens. And it may not have happened before, because in nature you'd hardly ever expect a damage which just damaged the lens in the eye of a newt. So it's not something that's been going on over millions of years, millions of times. It shows there's a wholeness within the whole system which can enable it to restore itself after damage. All of these are reasons for thinking that the whole body and the organs within it have fields, which in this case are called morphogenetic fields. I think that similar kinds of fields are within and around organisms, influencing their behaviour, imposing patterns on the activity of the nervous system, and that whole social groups have fields too. So a flock of birds or a school of fish are all part of a field of the whole social group. The generic name for these fields is morphic fields. Morphic fields include social fields, behavioural fields, mental fields, and morphogenetic fields. I shall come back to this later, together with some experimental data. But I want first to turn to the fourth of the aspects of unity in duality according to Nagarjuna, as interpreted by Tarabtoku, which is what he calls the conjunct nature of phenomena. I'm going to quote what Tarabtoku says: "The individual parts of the whole, while separate and distinct, in their unification form the wholeness of the phenomenon. The whole is again partaking in another phenomenon as one of its necessary components. Conversely, the individual parts of a certain phenomenon are themselves constituting a wholeness or unity composed by single parts. Thus, the opposing nature of part and whole are at the same time integral and inseparable from the conjunct nature of phenomena, unity and duality." The next picture shows the way in which systems are organized according to the holistic view of nature. My own work is couched within a more general philosophy, which is called the organismic or holistic view of nature, as opposed to the mechanistic reductionist view. And the holistic view of nature recognizes that at every level, the whole is more than the sum of the parts, but wholes are made up of parts. So there are subatomic particles in atoms, there are atoms in molecules, there are molecules in crystals. At each level, there's a pattern of organization which is more than the parts that make it up, but which depends on those parts being brought together in a higher unity. The same could be said of cells inside tissues, inside organisms, inside organs, inside organisms, and then as a higher level of the society of organisms, then of the ecosystem, finally of the whole planet, Gaia, then the solar system, then the galaxy, like those addresses that some of us used to write as children, ending up with the universe. So this fits perfectly with the idea of the conjunct nature of the unity of parts and wholes. And I think this is the way in which we need to understand nature if we're going to make sense of it. The old idea was that we could reduce everything to the smallest possible thing, thought to be the atom, but then the bottom dropped out of the atom, and we ended up with hundreds of subatomic particles. So those don't seem a very sure foundation for the whole structure of science anymore. So I don't think old-style reductionism really makes sense, but it's still a powerful habit of thought, which is why within biology the most prestigious and well-funded branch is molecular biology, precisely because it deals with the smallest things within living organisms, namely molecules. So this habit of reductionist thinking is still very strong within biology, although in many ways physics has gone beyond it. Now, I want now to turn, those are the four pairs of opposites of Nagarjuna, and I think they fit extremely well with the insights of modern physics and biology. I think all of them correspond pretty well with modern science, and some of them leave open implications and further possible explorations, like the nature of time and memory. So I think it's a fruitful way to look at modern science. But even more fruitful is the approach suggested by Tarab Turku in the three interpretations he makes of Nagarjuna, the first of which is the subject-object interdependent relationship. I'll read briefly what he says here. The subject pole as well as the object pole are interdependent and are rooted in the potential nature of the basic principle. Well, we hear something about this in quantum physics, the idea that the observer and the observed are interlinked and can't be separated. However, this insight in quantum physics isn't taken very seriously once you go beyond physics departments and discussions of the fundamentals of quantum theory. Within biology, it's certainly not taken very seriously by most biologists or psychologists. The problem here is that biology and academic psychology are still firmly rooted in a materialist model of the world. And according to the materialist model, the only reality is matter. Therefore, mind, consciousness, thought, and so on are epiphenomena or aspects of matter. Basically, it boils down to saying that the mind is the brain, or to put it more actively, mental activity is brain activity. So it means the whole of our mental world is compressed inside our head. The subject is separate from the object. Influences come in through the senses and through the nervous system. Once they get into the nervous system, that's that. It's all enclosed within the skin. Nothing goes out again, except, of course, through our actions. We can affect the world through acting, and indeed that's what we do, and our perceptions are indeed closely related to our actions. But apart from physical actions, there's no more mysterious interaction between the subject and the object of the kind implied by quantum theory. I think, in fact, there is a much greater interaction between subject and object than is usually admitted in biology or in psychology, academic psychology. I think the mind is much more extensive than the brain, and I think it stretches out far beyond the brain all the time. I think it does so through fields, which I'll try and explain in a minute. But first, I'll just use a simple analogy to try and make it clear what I mean. If you take a cell phone, a handy, and you look at the material structure, you have an object which you can hold in your hand. It's made up of material components which you can analyze. You can study the electrical activity going on inside it. All well and good, it's a material object. But the whole point of it is that it has invisible fields that bring information into it and take information out of it and connect it to transmitters and receivers and ultimately to other people's telephones all around the world. If you only studied the material structure of it, it wouldn't make sense in terms of what it does. But of course, that's what a materialist would do if he didn't know about the fields. I'm suggesting that our minds, our brains, our material structures, our nervous systems are material structures, but they're subject to influences through fields that both go out and come in, and that the mind is much more extensive than the brain. All of our minds are much more extensive than our brains right now. And I think one way of understanding this is through thinking about the process of vision. Just take the example of you seeing me standing here now. A simple sense experience. But of course it's not so simple, because what you see depends on your presuppositions, your mind, your interpretation, concepts, and so on. But what you're doing is forming an image of me. Now the conventional explanation of what's happening is that light comes from me, goes through the electromagnetic field, enters your eye, goes through the lens, inverted images form on both your retinas, changes occur in the cone cells, electrical impulses travel up the optic nerve, and there are patterns of electrical and chemical activity within the brain. So far, so good. All this can be and has been studied by the methods of neurophysiology, neurochemistry, and so forth. But then comes the mystery. You form a conscious image of me. There's no explanation within biology as to why that should happen at all. Indeed, some biologists say consciousness is irrelevant. It has no place in science, despite the fact that all science depends on consciousness. But it's an embarrassment for science because it ought not to happen. And this is why there's a huge industry among philosophers of trying to explain or explain away the mind-brain problem, as it's called, which is why we should have minds at all, because everything should go on just as well without them, according to this view. So this is the first mystery. You form a conscious image inside your brain, according to this theory. No one can explain why you should form a conscious image, nor indeed can explain why it's in the brain. And secondly, you experience your conscious image as being located not inside your brain, but I imagine outside the brain where I'm standing. What I'm suggesting is a theory so simple that it's very hard to understand. And that is that your image of me is an image in your mind, but it's located exactly where it seems to be, namely here. Your experience is what's happening. That's what I'm suggesting, that the world you see around you is around you. Those images are outside you where they seem to be, not inside you where you've been told they are. Oddly enough, our primary experience is something we've all been taught to deny in the name of a theory which eventually stems from 17th century biology in Europe. Actually, the theory of the retinal image, which led to this paradox, is one of the first things in the development of modern science. It was a theory developed by Johannes Kepler, who showed on optical principles that there's an inverted image on the retina. But he then said, once you've got the inverted image on the retina, the light comes in. He had no idea how you could explain vision. Kepler was deeply baffled by it. We don't see everything upside down in two tiny images. We see the world quite differently. And how does that happen? He had no idea, but he said it must all happen somehow inside the brain. And that's what people have believed ever since in the West. Although nobody's ever seen an image inside the brain, we take this on trust on the basis of this theory. The Swiss psychologist Jean Piaget studied the development of children's ideas about the world, and he showed that the average European child, until the age of 10 or 11, believes that when they see things, that there are influences going out from the eyes. Light comes in, yes, they know that, but something goes out too. This was the theory of vision believed by Plato, by most of the great philosophers of Greece and in the Arab world and in the Roman world, and by most medieval philosophers. It's also believed spontaneously by children in Europe. But Piaget said by the age of 10 or 11, the average European child learns the correct view, which is that thoughts and images are invisible things located inside the head. So we've all been taught that it's all inside the head. This is actually not something proven by science, it's an aspect of materialist philosophy, which was assumed from the start This is the foundation of virtue. The whole of modern academic neuroscience is based on this assumption that the mind's inside the head. Now, there are some people who've got a much more sophisticated view of perception, and one of them is Umberto Maturana. But the general run of ordinary science, on which billions of dollars a year are spent, it takes it for granted it's all in the head. Now, if I'm not playing with words, if there really is an outward projection of images as well as an inward movement of light, then we might be able to affect things just by looking at them. If our mind reaches out to touch what we're looking at, we may affect things or people or objects in general by just looking at them. In theory, we might even affect a distant star by looking at it over literally astronomical distances. Our minds reach out to touch everything we see. That's what I'm suggesting. Now, could this possibly be true? At first sight, it seems so totally improbable, and impossible indeed, that it's not even worth considering. And that's what I thought myself when I first had this idea. Then I thought, well, maybe you could test it scientifically. And then I thought, well, how could you test it? And then I hit on the idea of looking at people. Instead of looking at anything in general, what would happen if you look at a person? If you look at somebody from behind, if they don't know you're there, if they don't hear you or smell you or see them, you look through a glass window so they can't see you, smell you, hear you, or anything like that. Could they detect that you were looking at them from behind? Could there be such a thing as the sense of being stared at? Well, as soon as I asked this question, I realized that this is a common experience. I've had it myself. I've turned around and found people looking at me, or I've looked at others and I've seen them get restless and turn around. I talked to my friends and I found most people had it. And in fact, when my book in which I first discussed this, 7 Experiments That Could Change the World, was published in Germany, a German magazine, Die Woche, they did a survey in Germany of how common this was. They found that the great majority of Germans had had this experience. There was a sex difference, though. More women than men had had the experience of being looked at. And more men than women had had the experience of looking at others and making them turn around. Now, I imagine most people here have either experienced in the active or passive form or both. How many people here have experienced being looked at from behind or making others turn around? Well, that's certainly the great majority. Now, could this be true? Most people believe it. For most of my colleagues, the fact that most people believe it is a sure sign it must be false, and a superstition. Because educated people are told it can't happen. They've learned about the theory of vision, which is that only light comes into the eye and nothing goes out. So, could it be true? I looked through the scientific literature to see if there were any studies on this interesting phenomenon. Between 1890 and 1990, I found 4 papers in the scientific literature. One of them was a translation of one of the others, so there were only really 3. The subject had been ignored by virtually all scientists and all parapsychologists as well. There had been an incredibly powerful taboo about what's actually a very common everyday phenomenon. Why should the taboo be so powerful? I think partly because it defies the most fundamental assumption on which the Western theory of the mind has been based, that it's all in the brain. Ever since the beginnings of Western science, both Galileo and Kepler thought it was all inside the brain. That's one of the ways in which they rejected the medieval theories which were believed in Europe before that. And it's one of the ways in which Western intellectuals thought they'd risen above superstition, believed in by common uneducated people all over the world, all of whom believed that the eyes can have an influence on others, sometimes a bad influence through the evil eye, or a good influence through darshan, through the beneficial look of a holy man or woman. All of us here, I think, have had the benefit of the darshan of His Holiness the Dalai Lama today. In India, people travel hundreds of miles for that. And indeed, many people here have traveled hundreds of miles for it, because the look of a holy man is believed to confer blessings. Looks are considered to have an influence by ordinary people, uneducated people all over the world. And perhaps they're right. It'd be a frightening thought if the evil eye actually works, because it's something that rationalism has kept at bay, and one has to admit that this could be something that we might have to take more seriously. But right now, I'm not concerned with superstitions and protections against them, or whether the evil eye really exists, but whether the feeling of being stared at really exists or not. To test whether it exists or not, you can forget about all the taboos, you can do a very simple experiment. The simplest possible experiment costs nothing. Anybody in this room could do it as long as they could persuade someone else to do it with them. You need 2 people for this experiment. One person wears a blindfold. I use these airline blindfolds because they're free. At least you have to pay for the air ticket. But so one person is wearing a blindfold, and they sit with their back to somebody else. The person behind them either looks at the back of their neck or looks away and thinks of something else in a random series of trials. This random series can be decided by tossing a coin. Heads means look, tails means don't look. You signal when the trial begins by a neutral stimulus. I use this mechanical clicker, which gives a standard sound. So if you tap, then you may tap louder or softer, unconsciously giving clues to the other person. The mechanical clicker gives no clue. So you're sitting there wearing your blindfold, you hear a click, and you have to guess if you're being looked at or not. And you're right or you're wrong. Now, there's a 50% chance of being right by chance. So the score, 50% level means nothing's happening. But in fact, there are now hundreds of thousands of these trials have been done. I've done them with adults, I've done them in laboratory settings, I've also done them in primary schools. School children turn out to be more sensitive than adults, so I've often worked with children. And experiments have now been done in schools all over the world, in Germany, in Britain, in America, and in other countries. And the results are extraordinarily repeatable and extraordinarily significant and positive. The next slide shows the results of these experiments. In the looking trials, there's a huge positive effect. Far more people can tell when they're being looked. They're more right than wrong when they're being looked at. In the not looking trials, the control trials, there's no significant difference. This difference is significant at the statistical level of 10 to the power 27 to 1. It's an astronomically significant effect. When you add the 2 lots of scores together, then this overall effect is highly significant too. Why should there be such a dramatic difference between the looking and the not looking trials? At first this is puzzling, but when you think about it, it makes perfect sense. If we have a sense of being stared at, then it will work when we're being looked at. In these experiments, the control experiments, we're asking people to tell when they're not being looked at. We don't have a sense of not being looked at unless we're very vain. So in this situation, people are just guessing. So this is just what you'd expect if this is a real phenomenon. If people were cheating, or if they were hearing little sounds or subtle cues, then you'd expect the scores in both kinds of trials to go up, not just in the looking trials. I should add that this also works when you do it through windows, so you can eliminate sounds and smells completely. It even works through closed-circuit television. This has now been confirmed independently many, many times. So the common experience turns out to be supported by a massive amount of scientific evidence, which shows that the looker and the looked at are interconnected. The subject and the object are indeed interrelated, that the person who's the object of the subject's gaze is actually affected by it in a detectable manner, which can be shown scientifically and statistically to take place. This is found in animals too, not just in people. Dogs and cats can tell when they're being looked at by people. People can tell when they're being looked at by animals. And I think that in evolution, this probably evolved in the context of predator-prey relationships. If a prey animal could tell when a predator was looking at it, this would be of selective advantage. It would favor survival. It would be selected for by natural selection. So I think this, in fact, could be an extremely ancient ability. And I think the fact that stares being looked at is often frightening, and why there's so much folklore about it is because its evolutionary roots may lie in things that really are frightening, being looked at by predators. And this sensitivity may have evolved in relation to predators. I've done large-scale surveys and questionnaires about the natural history of this experience, and it happens most commonly in public places like the street, and it happens far the most commonly with male strangers, and who are the people who most people would perceive as the most potentially threatening. It happens also in the home, it happens in schools. A lot of school teachers find it a useful way of controlling their class. If they have naughty children at the back who have got their backs to them, they stare at them, and the children usually turn around quite quickly. It's one reason school teachers have been so cooperative in this research. Most of them have a professional interest in the subject. Anyone can do these experiments, and if you'd like to try it yourself, you can find the instructions on my website, which is www.sheldrake.org. And the whole website is available in German as well as English. So here's a way in which I think the subject and the object really are interrelated. I want now to turn to the body-mind relationships, which is the second aspect of unity in duality that Tarab Toku talked about. I think the whole body has a field, the whole mind has a field that projects out in accordance with attention, in the sense of being stared at, for example. Ad tendere, the Latin root of the word attention, means to stretch towards. Tendere means to stretch, ad means towards. Attention means to stretch the mind towards something. Intention means, intendere, means to stretch the mind into something. And I think our minds stretch out from our brains and from our bodies through intention as well. I think these intentions can have an effect at a distance, because I think they're carried by mental fields, which are like projections of our minds beyond the body. And I think our minds also affect other members of social groups to which we're bonded, because we're linked through social bonds to other members of our social group. These influences of the mind at a distance within the social group help to explain one of the other phenomena about which there's a huge taboo within science, namely telepathy. Scientists are not supposed to believe in telepathy, because if they do, it shows they're credulous, superstitious, childish, uneducated, or mystical. All of these are bad things within science. Nevertheless, most people believe in telepathy because they've experienced it. Survey after survey shows that most people in Western Europe and America and elsewhere in the world have actually experienced it. Again, for most of my colleagues, this is just proof that they haven't had a proper education, because if they experience it, they ought to know that it's actually not really telepathy, it's just chance coincidence, and they only remember when they're right, they forget when they're wrong, and so on. We've all been brought up to use that kind of argument to dismiss these phenomena. But I think rather than dismissing them, it's more scientific to investigate them and find out if they happen. If they do happen, it implies the mind extends beyond the brain. That's why there's such a big taboo about them. In fact, investigating these things is not terribly difficult, nor expensive, fortunately, because it's not very easy to get money for this research. And therefore, I've tried to find experiments that are as cheap as possible. The staring experiment is the best of all, because that's free. It's possible to do telepathy experiments, and it's easiest to do them with organisms that are most sensitive. Most modern Western people are not very good at it. Dogs and cats are much better. And I've concentrated on telepathy in animals for this reason. I summarized the results of my research in my book, Dogs That Know When Their Owners Are Coming Home, which is translated in German as Der siebte Sinn der Tiere. And in that book, I've examined many examples of telepathy. First of all, I've collected thousands of case studies from people about what their animals do, things they can't explain, which seem to them interesting. I've classified them. And it turns out there are very repeatable things that people have noticed. For example, many cat owners have found that their cats seem to know when they're planning to take the cat to the vet. The cat disappears. I heard this kind of story so frequently from cat owners, I decided to check whether this was in fact as common as it seemed. We did a survey of all 65 veterinary clinics listed in the North London Yellow Pages and asked them if they ever had a problem with people missing appointments with their cats. 64 out of 65 said it happened all the time. It was a big problem. The one remaining clinic said it happened so often they'd stopped having an appointment system for cats. So some people got so upset by never finding their cat, they tried making appointments with the vet when they were still at work, hoping the cat wouldn't overhear them on the telephone. And when they got home, the cat had still disappeared. The phenomenon that I've investigated most intensively is the ability of some dogs and cats to know when their owners are coming home. Many dogs, about 50% of dogs in fact, anticipate the arrival of the member of a family, a member of the household, by waiting at a door or a window. Cats do it too. Fewer cats do it, about 30% of cats, not necessarily because they're less sensitive. I think many of them are just less interested. And I received hundreds of stories from people, about 800 stories from people about dogs and cats knowing when their owners are coming home. And many of these were cases where it couldn't just be a matter of routine. A lot of women told me that they had husbands who worked irregular hours as doctors, taxi drivers, plumbers, lawyers, and so on. So they never knew when they'd come home. But the dog would always go and wait 20 minutes, half an hour before the man arrived, and this gave them the clue. And they then cooked the dinner so it was hot on the table when the man arrived home. I had very few stories from men about cooking meals for their female partners. So it didn't seem to be a matter of routine in many cases, and it wasn't just a matter of familiar car sounds, because it happened when people came home on planes, buses, bicycles, and taxis. The experiments I've been doing involve filming the place where the dog waits continuously the whole time the owner's out. With time-coded videotape, you can see exactly when the animal waits there. And then the people come home at randomly chosen times. They go out, they have a telephone pager. I choose the time at random. I page them to come home. They don't know in advance when they'll come. Nobody at home knows when they're coming. So they're randomly chosen times. And they come home in a taxi to avoid any familiar car sounds from at least 8 kilometers away. And the dogs that we've studied still know. They react at the time the person forms the intention to go home, even before they get into the taxi or other vehicle. So we've shown now in hundreds of cases that dogs reliably do this. I have a very good film of this. I'm not going to show it today because I want to show a different film today. But there is a very good film showing this. I've also published papers in scientific journals with full statistical details, and if you want the full details, I summarize them in my book, the book on animals. Since that book was published, first in 1999, I received hundreds more letters and reports from pet owners about extraordinary abilities of their animals. Some of the most surprising concerned parrots. It turns out that parrots, particularly African grey parrots, are among the most sensitive and telepathic of all animals. And many parrots can, of course, speak. This is a big advantage. People often say about dogs and cats, if only they could talk. But a lot of parrots can. It was thought for many years by scientists that parrots were only mechanically repeating words, parroting what they had heard. But studies in the United States by a dedicated parrot researcher called Irene Pepperberg have shown that African grey parrots not only use language meaningfully, but they can form abstract concepts. You can train a parrot, for example, to recognize red objects with particular shapes. Then you show the parrot a tray of different objects, things it's never seen before, and you say, give me the red one, and the parrot will pick up the red object, showing it's abstracted the concept of red. It's formed an abstraction. And in fact, parrots are better than the great apes. People have been training chimpanzees to communicate using sign language. Parrots actually are better at this kind of thing than apes, even though they're literally bird-brained. They have this huge advantage of using language. Well, one of the people that got in touch with me after my book was published was a young artist in New York who had been influenced by Pepperberg. She was fascinated by parrots. She'd always kept birds. She's been obsessed with parrots all her life. And she decided to try and teach her bird to learn language following Pepperberg's methods. In fact, she didn't follow them. She decided to go further. And instead of training the parrot in a rather mechanical way in the laboratory, she just talked to it as if it were a baby. And this parrot now has a vocabulary of about 700 words. The world record is 800. And it speaks in sentences. Now, she told me that her primary aim was to study communication in language by parrots, but she soon noticed this parrot seemed to be picking up on her thoughts telepathically. And she found, for example, one day she was looking at a magazine, at a picture of a car. The parrot was at the other end of the room, and it said, "That's a nice car." And another day she was thinking that she should phone her friend Bill, and while she was thinking that, the parrot shouted out, "Phone Bill now." And even more surprising, the parrot sleeps in her bedroom, and she still finds herself woken up repeatedly from her dreams by the parrot speaking loudly about what she's dreaming of. In one dream, she was dreaming about making a tape recording, and in the dream, she was just about to press the button on the tape recorder. She was woken up by the parrot saying, "Press the button." Well, this was off the end of the scale of anything I'd heard before about animals. So, of course, at the first opportunity, I went to visit her in Manhattan, New York, where she lives. I did some simple tests with the parrot there and then. We got some cards with pictures on. We went to another room, and the owner of the parrot, Aimee, was looking at a card with a picture of a girl on it. And at that moment, the parrot in another room, we hadn't said anything, said, "That's a girl." So I was extremely impressed by this, and I thought, well, we need to set up some proper controlled experiments to test this. What we did was we got photographs sealed in packets by a third party, a whole series of different photographs with objects on them that the parrot knows words for. In the experiments, the parrot was filmed on videotape continuously in one room, while Aimee went to another room with closed doors, no sound transfer possible, and she was filmed continuously on another video camera, opening these brown paper envelopes that contained pictures she hadn't seen before. She looked at each picture for 2 minutes, and the test was to see if the parrot said anything about the picture she was looking at. It's possible to calculate statistically the chances of the parrot saying these things at random and getting it right by chance. All the data have now been statistically analysed by an independent statistician. The odds against this being a chance phenomenon, the parrot actually saying what she's looking at, turn out to be extremely small. The odds are hundreds of thousands to 1 against this being a chance phenomenon. The parrot really does seem to be telepathic. Telepathy occurs between organisms with strong bonds. And in the human realm, the same happens. I've been investigating telepathy between mothers and babies, for example, and this is one of the areas where it happens at a very fundamental biological and physiological way. Some mothers experience a letting down of their milk. The milk starts coming out of the nipples when they're away from the baby, and this happens when the baby needs them, when it's crying unexpectedly, not just at regular feeding times. I've been doing a whole series of studies with the help of a midwife on mother-baby telepathy. I've also been doing a great deal of research recently on telephone telepathy, people's ability to know when others are phoning. This turns out to give extremely repeatable, highly significant results. I don't have time today to go into that, and these studies are still going on. We've recently extended them to email telepathy. A lot of people know when they're going to get an email from a particular person. Again, we're doing experiments that show that this is happening far more than you would expect by chance. These are some of the most, I think, some of the most positive and repeatable experiments ever carried out on telepathy. And if you want to try them for yourself, you can find the instructions on my website. I hope to have a live email experiment up and running within a few weeks. So keep your eyes on the website, and you could be some of the first people to take part. You can log on, you put on the names of 4 people that you think you might be able to respond to, and within 15 minutes you can be doing an actual experiment live online. The address again is www.sheldrake.org, O-R-G. And if you go to the home page, you can click on the Deutsch version if you want it in German. So telepathy is an expression of social bonds. It doesn't happen between strangers. It doesn't happen between people who don't know each other well. I think it's an aspect of the social field which continues to connect people even when they're far apart. The field that joins them doesn't break, it stretches. It's like an invisible connecting tube between different members of the social group when they're at a distance. This makes sense in terms of a field theory. It doesn't make sense in terms of the idea that it's all inside the brain. So I think this mind-body, the duality that Western science and also Tarab Turku are talking about is something which becomes much less puzzling when we recognize the mind is much more extensive than the body. Of course it interacts with the brain, just like impulses coming into a mobile telephone interact with the processes going on inside the phone, and what happens inside the phone influences what goes out. Of course the brain is important for this, but it's not all just in the brain. The third duality that Tarab Turku talks about is the matter-energy duality, and I think it's actually better to see it as energy-field duality. But I won't talk more about this because we have 2 physicists with us at this conference who are going to be talking tomorrow on this subject. Well, they may touch on this subject. I don't know what they're going to say. I'm not totally telepathic myself. But I just, in the last 2 or 3 minutes, like to end with some more general remarks. I myself am a Christian, and from the Christian point of view, the fundamental basis of everything is unity in Trinity. So I come to the idea of unity in duality with considerable fellow feeling. This is a very similar idea to unity in Trinity. Some Christian theologians, such as Saint Bonaventure in the Middle Ages, suggested that the Trinity, being the fundamental nature of God, is reflected in every aspect of nature and creation. And I think that this indeed is an idea which runs parallel in some ways to the insights that come through the unity and duality from the Nagarjuna tradition through Tibetan Buddhism. The Trinity, according to theologians, is a mystery. It's the ultimate divine nature is far beyond our powers of understanding, and we can only attempt to understand it through metaphor. There have been a variety of metaphors in the history of Christian thought about the nature of the Trinity, one of which is a little bit like some ideas we've just been discussing. This is St. Augustine's psychological model of the Trinity, where the Father is the knower, the Son is the known, and the Spirit, the Holy Spirit, is the joy of knowing. So you have the knower, the known, and the interconnection between them in joy, which is the fundamental pattern of the Trinity. This is very like certain Hindu models of the ultimate nature of reality. For example, Sat, Chit, Ananda, being, knowledge, bliss, is one of the Hindu views of understanding ultimate reality. And I think that this was also reflected in some of these unity and duality ideas that we've been talking about here. Another Christian model of the Trinity, this is by no means an exhaustive discussion of the theology of the Trinity, which I'm not qualified to do, but another model that I find particularly helpful is the simple idea of the Word and the Spirit. One of the fundamental concepts or metaphors in the Christian and Jewish tradition is the Word. By this it means the spoken word, not the written word. The spoken word is living, dynamic, vibratory, and fundamental. It shows there's a fundamental vibratory reality. But if you think about words, for example, our own words, in our own speaking, the word has two aspects. On the one hand, it has the breath. Without breathing out, I couldn't be speaking now. So there's an outward flow of breath. And the word for breath is spirit. And the Holy Spirit is really the breath of life in the whole universe, the flow of energy, the wind, the breath. These are the various metaphors of the Spirit. I see it as the dynamical principle of creation, which is like energy, the life spirit, the current of life, and in our own case, the breath. The word, the spoken word, depends on thoughts, connections, meanings, relationships. All these lie behind it. It's a pattern that's imposed on the flow of the breath. If you just had words in your mind with no breath, they'd be silent and ineffective. For a word to work, you have to have both the flow of the breath and the pattern, the meaning, the relationship implied in the word, the vibrations which work together with the flow. They work together, although you can distinguish between word and breath. And the speaker is, of course, in the Christian model of the Trinity, God. So you have God the Father, who's the speaker, and you have the Word and the Spirit as two aspects, the unity, the duality within the unity. There are many other metaphors of the Holy Trinity, which I think are fruitful, productive, and fascinating. And I think quite a number of them have parallels with these insights of Nagarjuna and the Tibetan tradition that we've been talking about today. Time's up, so I'll just end by saying that I think we stand on the threshold of a new phase of exploration, both within science and in dialogue between a more holistic science and these traditions of philosophy from both East and West, which have been separated for far too long. And this conference, I think, is one step towards this new dialogue and this new process of discovery. Thank you.
Herr Sheldrake, wir bedanken uns für diesen exzellenten Vortrag. Für alle, die ihre Bücher signiert bekommen haben möchten, Rupert Sheldrake wird die Bücher signieren am Eingang der Halle jetzt anschließend. Und für diejenigen, die seine Website anschauen wollen, das ist nochmal www.sheldrake.org. O-R-G.
Infinite perception, opening the doors of 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 perception.